Okay, let's go ahead and get started. Good morning, everyone. My name is Anis Sheikh. I'm with the Google Network Infrastructure team. Welcome to day 2 of HotNets. Our first session this morning is an interesting mix of networking and systems, one of my favorite spaces around network virtualization. We have 4 great talks. We'll start off with Aleksandr Zavodovski, third-year PhD student from University of Helsinki, working on edge computing-related things. This talk is ICON. It's about distributed and self-organizing way of managing containerized services. So take it away, Alex.
So I'm going to be talking about intelligent containers that form overlays. So imagine the following setting. We have an application in the United States that utilizes some edge services. Edge services are about being close to end user, providing services with minimal latency. And as you might guess, it's not so difficult to pre-deploy edge services in US. You have all those fancy Azure Stack, CloudFront, and so on. Then imagine some user group appears in the region of Indonesia, say, and they discover that application, start to actively use it, but they are not so happy because they do not have those edge providers. And suddenly application management faces the challenge, where do we find those edge service in that region? So that setting might be familiar from you. It might remind you something of CDN for services. But that's not exactly what we're doing. No. We are developing open standards that will render decentralized solution, and that will remind you by its organization something of internet, but it's for distributing, provisioning of services. So we are motivated by growing demand for edge computing. We think that applications should unfold themselves towards edge autonomously without major administrative efforts. And those administrators, they should set only high-level objective to such applications. And as you saw from the example, those solutions must adapt to the changing environments. If you imagine some large user groups and flash crowd is forming somewhere, then application will react or even proactively act. So we are aiming to define some common standards and conventions for self-organized service provisioning, and that may work not only for edge, but at broader scale, because we might optimize for budget, not for latency, for getting certain hardware at certain price, and so on. So what is our intelligent container? It's a virtualized entity containing a service, so it might be built on top of Docker container, even virtual machine, unikernel, dependent on concrete application needs. And it's oriented towards microservices architecture. So its application consists of various services, some of them, for example, are suitable for edge. How it's different? It observes its environment, it monitors where user requests are coming from, and it discovers potential deployment locations, like where it could serve users better or follow the optimization goals more successfully. And once it gathers the information about environment, it acts, for example, migrating closer to end users, or even terminating if there are no users to serve. So how it operates. On the top of all, you see application owner. That is an entity or person responsible for setting business goals for application, like how good service it must provide for end users, how much budget we have to spend, and so on. So only like 2 knobs rotating. And originally, ICON may start unfolding themselves from the cloud. These might be multiple clouds or some single cloud or cloudlet. So then user requests are starting to come. Noticed where they come from. Intelligent container discovers on-path cloudlet. I will talk a bit later. What are those fancy clouds here? Then it can deploy replica of itself closer to end users. And then users switch to use edge, not going anymore to the cloud, but utilizing service that is very close to them. So same for migration. Here you see intelligent container migrating towards larger user crowd. As you know, icons form overlay. So imagine setting where some Japanese game developers develop some fancy game initially for Japanese market. Then suddenly game become popular in Europe, New Zealand, New York. So if they deploy the application with intelligent container, they automatically go to serve those users. And then New York container starts serving also South America, so getting enough requests from Rio, it deploys replica of itself in Brazil. So the structure they form is tree-like. Tree is forming like organically because parent knows its children and children remember its parent. It's quite efficient to propagate control information and also those key performance indicators that application owner might use in determining how application should function. We are also not close to other topologies, but first of all, we thought of tree. So what are those fancy things? We call them independent edge provider. And the nice thing about our standard is that anyone can establish such a thing. Like anyone can establish an internet router, ISP. In our vision, it's possible for anyone, so it's open. They will be discovered by icons, and I will show later how. But for the present time, those can be those cloud fronts, Azure stack, those can be telecom edge servers, or we might even consider those crowdsourced solutions that are gaining popularity nowadays. Which is good about them, they have their machines very close to end users. So internally, independent edge provider is built on top of Kubernetes, Mesos, or there are many good cluster management frameworks. But what they miss service that some container coming from outside might contact and negotiate on its deployment slot, negotiate on required hardware, price, payment methods, and so on. And of course, those entities are motivated because they expect some revenue coming from those containers. So we were considering smart contracts as mean of contractual agreement because it's very dynamic. So smart contracts are familiar from Ethereum network and other blockchain platforms. So next, how intelligent container will discover those independent providers. We sketched simple DNS discovery mechanism so that it does not require any controllers, any special services. Once you establish your independent edge provider, you register it in the DNS, and as intelligent container traces route to its end users, it will discover on-path domains, and given that there is an SRV record in domain name server, then those locations will be discovered. And then intelligent container can contact that negotiation service and negotiate on its possible deployment. Intelligence of containers. So far, they have not been really intelligent. Yeah, sorry about that. Yeah. Well, it's governed by utility function, and control knobs I showed you are the weights of that control function. Ideally, the application owner can hot swap entire utility function. And there are thresholds. When certain thresholds is exceeded, a container might deploy a replica of itself. It might migrate, or in case utility falls below a certain threshold, it might just terminate. There are also more complex versions possible, but so far they are in the process of development. So what open questions we have? Of course, intelligence is very much dependent on the applications. As yesterday I heard from CDN caching paper, reinforcement learning is not necessarily good. Thanks. Yeah, so discovery of the closest icon, how containers how end users will discover the container that is closest to them. We have some Anycast solution. We might mimic CDN approach, how they discover the content. And basically, the solution that would always work and won't require any kind of financial investment. It's just redirection. First request comes to the cloud, and then it's redirected to the closest intelligent container. But it's not very efficient, of course. Then for security, if anyone establishes facilities where a container can run, those containers are not protected from malicious entities, and practically with the root access to some edge server, one can get all the data, all the algorithms that container uses. So how we were thinking to tackle this? Here, another buzzword, trusted execution environments probably can be used for that. And we're also considering smart contracts the best option. So in future, we plan implementing container yard application that will build on top of Kubernetes or other cluster management system. We plan to standardize negotiation protocols, so like all routers support IP, all those places capable of running and deploying containers, they will also support some standardized protocol, how you negotiate if you wish to deploy your service there. Then sophisticated intelligence. It would be nice to be able to proactively predict where end users will be, and so container not only reacting to the incoming flow, but they deploy themselves proactively. So there is a space for game theoretic analysis because there might be competing applications using icon technology, and we are interested to what kind of market this will lead. And special issues, because containers are generally specialized, and you may also pack some database as intelligent container, and then it will follow different optimization targets. And there is a problem how you coordinate your edge service with that database, how they will track each other and communicate with each other. So that's what we are planning to do. And to summarize why we are developing such thing. So we want to tackle growing demand for edge computing. We want to reduce cloud monopoly. Last year there was an interesting paper at HotNets they called that thing feudalism of the internet. Like every big provider contains major areas of the internet. So we want to develop open infrastructure standards, to develop ad hoc developments, deployment of services, reduce administrative overhead, and taking advantage of autonomous decision-making leads to faster adaptation. Because if you have some optimizer sitting in the cloud, then it has to gather the picture of the world, then it has to compute big solution, then it has to propagate back its decisions, and probably then it's already too late. In our evaluation, we have shown that taking autonomous local decisions provides faster reaction times. So I wish to thank you, and I welcome questions, suggestions. I would be happy to answer those. Please. Thank you.
Got a couple of minutes for questions?
So the usual problem with these kinds of ideas is that the security situation is awful. I can write a DDoS application and now forward it out via containers everywhere across the network. So how do you deal with that, given that, I mean, it may represent, it can equally represent a bug in the application, which is now suddenly spread in many directions. And I didn't get a good sense of the protections.
Yes, that's a very good point, and we were thinking of that. And so far, we consider that those independent edge providers, they are protected by virtualization technology, so containers run in the isolated space. But to protect secrets of container, we put probably them in trusted execution environments. There are, of course, problems with that technology, and we rely on the previous work.
Yeah. Giving with a container is fine. The problem is that you've now distributed the ability to create things over the network.
Yes, yes.
And maybe I missed it, but I didn't catch a sense of how you constrain the bandwidth for the individual containers.
Bandwidth. Yes, that's also a good question. But when container wants to migrate to some deployment spot, it might negotiate on the bandwidth it wishes to consume, and it might be restricted. For example, in the Docker, you might deploy some special interface that restricts usage of bandwidth.
Okay.
Okay, thank you.
Hi, Alex from Stanford.
Yeah, thank you.
I was wondering, do you take into account traffic patterns over time with your deployment? Because, for instance, during peak hours, maybe there's a lot of requests coming from the US, and if you're constantly taking down containers and deploying them again, it might kind of damage performance.
That's a good point. Yes, we plan to incorporate that way of thinking when developing that intelligence part of the container. So it will be able to detect cyclical patterns and proactively move where the users will be. Yeah, but intelligent is a difficult thing, so I hope we will manage to do it. Yeah, yeah, thank you. Yeah, thank you.
Hello? It's not work.
Is it on? Is that mic on?
My question is, have you ever thought contribute or worked about the cloud native computing foundation? It's like for us, we're going to have a 5G commercial deployment, and we are looking at a cloud native solution. Because SDA architecture, service-based architecture, as defined by 5G 3GPP standardization. So there are a lot of cloud native microservice things. And then they're going to be implemented based on different technologies, one like a container, those type of things. So have you ever thought to contribute this one to CNCF?
I think we should definitely consider that cloud native technology that you suggest, yes.
Thank you.
Thank you.
Any other questions? Maybe I'll ask one more while Amit is coming up. I'm a little curious how important the kind of IEP, the independent edge provider part of the story is. It seems to me that the software layer that self-manages these container services is sort of the key thing here, although I think other multi-cloud solutions also probably are trying to do similar things, maybe without the auto migration and self-organizing part.
Yes, that's interesting point also. We are aiming to open, say, a new market for those IPs to come, because when they can be discovered, when they can get some revenue from those dynamically coming containers, then there is a reason to establish such facilities. But basically, you have today those MEC servers and CloudFronts. If you put our container yard application that is able to take icons, then that's it. You do not need anything special. They will be dynamically discovered, and containers will come and provide revenue.
Thanks,
Yes,
Aleksandr.
thank you very much.